We have about 2 minutes if anybody has a specific question for Jan.
Okay.
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 Okay, we're done. You did good.
Okay, our next speaker will be Vladimir Ginsburg. Are we rolling? Good. Okay. We're changing his microphone. We're really running fast here, so in brief, Vladimir Ginsburg was born in Moscow. He got a Master of Science in Mechanical Engineering, a PhD in Technical Science. He moved to the United States in 1974. He has over 50 patents. He does physics research, mostly on spiral field theory, which is part of what he's going to cover today. He's got 3 books out on the subject, including the book, The Unification of Strong, Gravitational, and Electric Forces, which is available on the internet. So here is Dr. Vladimir Ginsburg.
Ladies and gentlemen, thank you very much. I understand everybody is tired and very hungry, so please consider my presentation, humble presentation, as just appetizer for next reception.
Try to use this whenever possible.
All right. The subject is actually its essence of 4-dimensional spiral string theory. Very ambitious name for the theory, and the difference is it is not 8-dimensional or 9-dimensional, it is 4-dimensional, which all of us can understand. In brief, what you are going to hear is basically a new interpretation of constancy of velocity of light, new interpretation of subluminal and superluminal velocity, new interpretation of zero-point energy, new understanding of elementary particles and photons, their origin, new understanding of positive and negative energy and the mechanism of absorbing and releasing zero-point energy. And of course, I want to be very modest. Of course, it should cover a unification of relativity and quantum mechanics, and of course, a unification of strong gravitation and electric forces. So the agenda is very modest, and I hope you have enough patience to ridicule me later on my ambitious goal, but this is my goal. Next.
Can you put that in your... Was there a battery dying? Yeah, it sounds like it. Okay. I think it's right. Now, you can continue. Just a moment, please. Thank you, sir.
Okay, my zero-point energy recharged, so I will be continuing speaking. Please, next. What I would like us to go first to the basics, and the basics in the spiral grain of our universe. It starts from very abstract concept, and I admire your audience. You have a very great imagination. The spiral principle of the universe based on very simple principle, abstract principle. Every line is a spiral. So accept it as right now the statement for granted, and later on you really appreciate what it means. So what it means if, for example, this is a line, and I use a microscope, and this is a circle, and I will enlarge the circle to this size, you will see instead of a line, at this point, you will see the spiral. The same thing if now I look at this portion of the spiral as a circle, and also look at the microscope, instead of this line, you will see now this spiral. The same thing, this circle under microscope, you will enlarge, you will see this spiral. But not yet. But it also works backwards. Now, instead of using microscope, let's use telescope. So now this line, if you use telescope, will be reduced, and you'll see it's this line, actually the part of the larger spiral. The same thing, this part of the line is under telescope will be seen as a part of the larger spiral. So you already understand that the spiral principle goes in enlargements and in direction of enlargements and in direction of decreasing dimensions. Okay, please, next. Now, what's the point out of all what I said? The examples. The examples of this spiral, around spiral, around spiral. So you can imagine, like you have a spiral, I call it a leading spiral. And you can imagine that the trailing spiral is...
Just a moment. I'm going to reposition this.
And trailing spiral is around the leading spiral. Now you can imagine this trailing spiral as a leading spiral for the next spiral, and so on and so on. Okay, so the examples, let's say odd space dimensions. By the way, this spiral, around spiral and spiral called helicola. Let's start from just a straight line. Then the next dimension will be the spiral around this straight line. Then next dimension will be now this spiral is round around this spiral, and this spiral is round around the straight line. Okay, it will be fifth-dimensional helicola. Next, please. For even space dimension, we will start from a circle. Now you have a torus where the trailing spiral wound around the circle, which is leading spiral, and then the sixth dimension, it will be, excuse me, yeah, sixth dimension, you will see this spiral around this spiral and around the circle. And so on, so on. You can continue this spiral around spiral around spiral. Please, next. Now, why I'm wasting your time on this spiral around spiral? What it has to do with us. And I can tell you, it has everything to do with us, because everybody sitting in this room is moving around billions of paths of helicola. And what are these paths? I just give you a small example. Okay, this is the path of the sun around the center of a galaxy. Okay, now this would be the path of our Earth as the sun moves. Okay, so our path is not elliptical. Forget about what we taught in school. It has nothing to do. Our path is helical. Okay, what the moon is doing? Moon is moving around this path, around the path of the Earth. Okay, what is the satellite moving around the moon is going to do? Okay, it will move. It will create another level of helicola. Gentlemen, helicola is a part of us, and we are moving along we are moving simultaneously along all the levels of helicola. It doesn't stop right here where the sun moves, because the center of a galaxy also moves. Okay, and so on. This process of our picture about elliptical orbits plus Big Bang, when everything flies apart, is absolutely a wrong picture of our universe. Our universe is moving harmoniously along spiral paths. Thank you. Next, please. Now, of course, I would be over-ambitious if I will tell you, gentlemen, I developed the theory which describes absolutely every movement in the universe. Okay, I really don't have time. I'm 69 years old, and I feel I need a little bit more time to do that. Okay, but what I decided to do, I decided to go backwards and say, well, let's find out what would be the simplest case of helicola. And of course, the simplest case of helicola would be the helicola, which would contain only one leading spiral and one trailing spiral. Okay, this is the minimum what is required to be a helicola. Okay, so now what you have, what I call a definition of relativistic torus. And what you have the leading spiral as a circle, and you have a trailing spiral in the form of torus. Okay? Now let's think about in the simplistic, the most simple assumptions, because you can imagine large torus, small torus, you can imagine any relationship in a torus. Out of all possible combination, believe me or not, just take it for granted for a moment. The simplest, not only simplest combination of dimensions and velocities would be three relationships. First, number one is the difference between the radius of the trailing spiral, which is called here R2, and radius of the leading spiral, R1, is equal R sub I. And R sub I is called for inversion radius. In a moment, you will understand why I call it inversion. Moreover, this difference is constant for a set of toruses, of tori, because the plural for toruses is tori. The set of tori has constant difference between trailing and leading spiral. Is it crazy assumption? I think it's a reasonable assumption. It could be, okay? I don't believe you could shoot me down for making this assumption. Later on, you will understand how rewarding this assumption is going to be. Second assumption, it calls that cosine of slope angle of the trailing spiral is equal ratio of the radius of trailing and leading spiral. By the way, this assumption actually becomes even more simple. Eventually, it leads to the length of the leading spiral and length of the one winding of the trailing spiral are equal to each other. It's the same thing, what I said in this ratio. Mathematically, it's absolutely the same thing. Okay, is it crazy assumption? Okay. You say, well, of course, you can assume something else. It could be equal 2 or 3 times or 4 times, but I don't believe it's crazy. I don't believe you're going to throw me out of this podium for making this assumption. Now, this is purely geometrical assumption. And if you will make just this assumption, 2 assumptions, I can tell you, you can calculate what is going to happen with this torus if you are going to change its relative dimensions to infinity, to 0, I'm talking about radius, to infinity, 0, and to negative infinity. You have enough data or enough information to do all calculations and to see how shape of this torus is going to change if you are going to change its radius. But it is going, in that case, it's going to be purely geometrical model, and it's going to be only 3-dimensional model, which is not going to represent our real world. To represent our real world, we have to add time, so it's becoming space-time. It will have space-time properties. To add space-time properties, now we are making an assumption that the velocity along the spiral path of the trailing spiral is equal to the velocity of light. Okay? Anybody wants to throw me out of this podium now for making that? Okay, I don't see anybody doing that. Now, but at the same time, he said, so what? Everybody knows that there is a limited velocity. Well, so big deal, he made this assumption. It's a very logical, simple assumption, okay? But there is underground a trick behind that. It really, I'm using demeaning word for trick. Actually, it's a concept, underlying concept. What it does, this simple assumption, it replaces our common concept of constancy of speed of light to the constancy of only spiral velocity along the spiral path. It has nothing to do with all the other velocities. And what are the other velocities? The spiral, what is spiral, helical spiral? How you create helical spiral? You make a circle, okay, and then you move. Okay? So you have rotational velocity and you have a translational velocity, two components, and geometrical sum of these two velocities becoming spiral velocity. So I said velocity, spiral velocity is constant. I didn't say anything about rotational velocity. I didn't say anything about translational velocity. Then you say, well, if there should be a relationship. Yeah, it's Pythagoras' theorem. Okay, square of spiral velocity is equal square of rotational velocity plus square of translational velocity. So if spiral velocity is maximum, it means rotational velocity must be less than spiral velocity and translational velocity must be less than spiral velocity. It's not so. I didn't say that. It is, you may make this assumption, but I didn't say that. So when I said a constant spiral velocity, I presume that either translational or rotational velocity could be either subluminal or superluminal. Okay, next please. The same assumptions are done for definition of relativistic helix. It's absolutely the similar assumption. The only difference is instead of cosine of slope angle, now we have sine of slope angle. But the other two assumptions, exactly the same. Next please. Now, if somebody likes to do just exercise, just use my previous assumptions, and you can build a complete theory on your own. Complete theory which would describe all 5 basic concepts I describe, what theory can describe. You can do it on your own. You have already enough assumptions, but mathematical base to build the theory. What I want to do, because of time limitation, I am going to briefly to say what you can do. Okay, the first thing what you can do is that any scientist or any research worker, what it does, well, all right, I have these assumptions, then I can investigate what's going to happen because I can derive based on these assumptions. Of course, I know what would be the ratio of the radius of the trailing string in respect to leading string, and I can plot all these, for example, dimensions, let's say number of windings, length of each spiral, okay, I can draw the shape as a function of this relative radius, but R2 to R1, okay? Now, this is what is it, I made a plot. If you make B, which is the ratio of the radius, 2.3, it will look like this, okay? Now, remember we said this radius, inversion radius is constant, okay? Now, if I make B sub 1 is 1.1, it means I reduce the radius, okay, it becomes thinner, number of winding decreases, okay? And if I will make B is equal to 1, it means spiral radius of trailing spiral and leading spiral are equal to each other, it's becoming as a circle, okay? Now, let's see what speed-wise is going to happen. Speed-wise is happening if the B is very large, let's say goes to infinity, in that case, rotational velocity becoming equal to velocity of light. Translational velocity reduces to 0, okay? And it's becoming, actually it's becoming like a long, infinitely long string because infinite radius, okay? Now, as the radius decreases, it's becoming more curly, number of winding decreases, okay? Rotational velocity decreases, but translational velocity increases, according to Pythagoras' theorem, okay? Now, here you have, when you have very slim torus, now you have rotational velocity approaching to the velocity of light. And eventually, when these two radius are equal to each other, it's becoming what I call ZP zero-point energy ring. The string propagates with the velocity of light at this point, okay? Now, here we have to get into stretch our imagination. I assume, for example, that the spiral at this point is counterclockwise. Okay? Now, at this point, it's no longer either counterclockwise or clockwise. It's just becoming a string. It doesn't have any spin altogether. Okay? What is going to happen if I will continue to reduce radius? Because nobody forbids me to become less than 1. Okay, let's next. Now I'm going to less than 1, and what you will see, unfortunately, it's not in the same drawing, but the, excuse me, but the windings now no longer is counterclockwise. Now they're clockwise. Okay, their direction of spin changes. And for a long period of time, I thought this is all what is happening. But actually, later on, I learned it is not all what is happening. It is not only the spiral changes its spin, spiral changes its vertness. Now you have a new term. What it means, vertness? It means the trailing spiral becoming inverted inside out. It means if, for example, you will see the, let's say when it's b is greater than 1 and your tape, you mark this spiral like a tape with red and inside with blue. At this point, red is becoming inside and blue is outside. It is very, very important property of the spiral, not only to change the spin, but to change its vertness. Now, when it changes its vertness, and you continue to investigate what is happening, now this spiral is inverted inside out, okay? And what is happening? Translational velocity decreases, rotational velocity continues to increase, okay? And when it's becoming b is equal 0.5, the spiral rotational velocity will be equal to velocity of light, and translational velocity becomes equal to 0. This is exactly the same conditions, symmetrical to what was when the spiral was when b sub 1 was infinite. But it is inverted, and this is what we have a case of asymmetrical symmetry. On one hand, we have completely two different sizes. Outverted spiral is great, goes to infinity, and symmetrical portion goes inside. In the size-wise, it's like imploded. But all the properties, if you will see these speeds here, you will find the comparable speeds for outverted spiral. Okay? So you have a case of inverted and outverted trailing spiral. Now, so far, all parameters, when we change B1 from 0.5 to plus infinity, so far all parameters are expressed with real numbers. So in Pythagoras' theorem, you have always rotational velocity and translational velocity less than the velocity of light. Everything is kosher. And for many years, I said, this is it, because after that, I'm going to get imaginary numbers. And according to many people say, if you get into the imaginary world, it is not our world, it's somebody else's world. And actually, my education really hurt me, because I was subjective, rejecting everything what is going to happen below 0.5. Eventually, when I overcome this weakness, okay, let's go next. I said, well, I'm going to investigate what is going to happen inside. And when I started to investigate, what I found, now the spiral which goes inside, and I will show you just right now briefly, and then I will show a much clearer picture of that. What is going to happen, rotational velocity now becomes greater than velocity of light. it's all coming from the assumption I made before. You just continue to do calculations, and we find rotational velocity becoming greater than velocity of light. What's happening with translational velocity is becoming imaginary. Wow. Okay, what shall I do? What physical meaning of this? The only thing, if you remember that Pythagoras theorem works with squares, okay? And square of imaginary number is a negative number, okay? And square of velocity is a part of the equation for energy. Now we are getting, even I'm not assuming nothing, but I'm getting a hint, maybe something which is related to negative energy is hidden in this construction. Okay, let's go to the next. Okay, and these are the shapes you are getting, but I want to show you in the simple form. It will be next, please. In the simple form, so it will be next, please. Next one? Yes, yes. Okay, so what I show here, I show the cross section of the torus. So it's much easier. So in that case, you can see only a rotational component. Okay, but it's much clearer understanding of the transformation of the torus. So we start when we have infinite radius, positive radius. So actually, it's becoming infinitely large. So it's like a straight line. We call straight string. Okay, this is our 0-point energy ring, which I described you before. Now, as we reduce our radius, this is radius 2 now. Okay, this is the shape of the torus. Okay. Now we continue to reduce this 1.5, the torus becoming smaller, okay, and we said it's counterclockwise, as we mentioned before, okay, and eventually, remember we discussed when it reduces to 0-point energy ring, now it's becoming like this. Now I continue to reduce, be inverted, this is what we already discussed, this is 0.4, I believe, or 0.6, okay, I cannot see it very well, okay, now you have inverted clockwise. Okay, we continue to this point. Can you just drop it down? Excuse me. Can you drop it down a little bit? No. The previous one. Previous one, just lower. Make it lower. No. The one you showed before, just make it lower.
This one?
No. Next. No, before table. Yes. Yeah. Okay. Yeah, we couldn't see this. Now we can, at 0.5, you can see this like torus like touching. Okay. Now what is going to happen when it's less than 0.5? You see this overlapping of inner windings of the torus start to overlap. Okay. It's continue to overlap until it's becoming is a maximum point energy ring. Now, as I mentioned to you, this velocity of this rotational velocity is greater than the velocity of light. As we decrease radius, it's becoming greater and increases to infinity. So now we have maximum point energy ring with the velocity equal to infinity. And say, well, Vladimir, you're crazy. You told us about constancy of velocity of string velocity. Yeah, it is constant. At the same time, when this rotational velocity increases to infinity as a real number, translational velocity increases to infinity as an imaginary number, and sum of the squares of this velocity is equal to velocity of light. So now we have a case when in this model we have all possible velocities, and at the same time we maintain the law of constancy velocity of light. But it is only applied to the spiral, velocity along the spiral. Okay, now what happened now next? Now we are at the 0 point. This is the radius of leading string is equal to 0. As common sense person said, this is it, okay? I reached the 0. As a mathematician, I said, well, what's the big deal about 0?
from 0 to infinity is one way, from 0 to negative infinity is another halfway. I have to investigate what is going to have from 0 to negative infinity. Okay? Now, what's happening at this point? As I mentioned to you, at the point of 1, okay, we have inversion of the trailing string from being outverted to becoming inverted. What's happening at 0 point? Now, a leading string, which is a circle, instead of being outverted, becoming inverted. We have the second inversion. Okay. Now it's just because it's becoming more 2 inversions, it's a little bit too much to swallow before reception. Okay. But mathematically, this is what's happening. Now, when it's becoming inverted, now this is the shape of the toroidal. Okay. So instead of being a wound inside of the 0 point energy ring, it's becoming outverted outside of this, outside of the 0 point energy and maximum point energy ring. And as you continue to decrease or increase negative value, it's becoming symmetrical to what we had before. The only difference is here our velocity is approaching to the velocity of light from the less than velocity of light. Here we are approaching velocity of light from above of the velocity of light. Now you have a complete picture of the torus, which covers all velocities below velocity of light and all velocities above velocity of light, but both of them coming down at the infinity, they are coming to velocity of light. Okay, next please.
Where can we get a copy of your paper?
Pardon?
Where can we get a copy of your paper?
I will give you my website, www.helicola, Helicola, helicola.com, and I will email you the paper.
Thank you.
Okay. All right. Now, this is good that you don't see the equations. Okay. The only thing I want you to do is just memorize them. Okay, and we will discuss during reception. Okay. What I wanted to tell you what is in these equations. These all equations you can derive on your own. Okay. Believe me, there is no complexity, as long as, of course, you have to remember this Pythagoras theorem, okay? And if you know the square of negative number, the square of imaginary number is negative, this is all what you need, okay? So equation is for leading spiral of the torus and trailing spiral of the torus, leading spiral of helix, and the trailing spiral of, so this is all, how to say, unless I made a mistake in the derivation, you will correct me, okay? But if none of us are going to make a mistake, we'll get the same equations, okay? Let's not go next, okay? Okay, now, what got me excited, and I have probably only 5 minutes left, all right, about 5 minutes. No, not yet. I said I have 5 minutes left, right? Okay. What got me excited? So far, I didn't say anything about particles. I didn't say anything about ether, about the 0 point energy, except I used terminology, which you can change, okay? So far, we talk about space-time properties of the tori, the same, or the torus. The same, I didn't describe it here, the same time you can describe space-time properties of the helix. Now, how we get from these 4-dimensional space-time elements into real world, okay? Now, here we have to have very simple assumptions. What happened to be, okay, I said, well, so how I will calibrate this model so it will simulate, for example, hydrogen atom, okay? And the only thing I have to do is assume that the mass or electric charge of this torus is proportional to the ratio of the radius leading and trailing spirals. Okay? This is only an assumption I'm making. Okay? Now, once I made these assumptions, now I can derive all the equations for masses, for electric charges, for angular momentum, magnetic moment. I can apply now all standard equations which are applicable to elementary particles. Next, please. What I'm using the constants everybody uses. Okay. What I'm getting out of this calibration, that inversion radius is equal to this is the k, which is, I don't want to describe the equation. It's just a function of electric charge, mass, and the square of velocity of light. Okay? And also fundamental frequency, which is also a function of known constants. Next, please. Okay. Now, once I know how to calculate all physical properties of tori, okay, I haven't said yet what is elementary particle yet. I said I know what tori. I know tori can be from plus infinity to negative infinity. Okay, and what I notice that tori which are expressed with real numbers, okay, have masses slightly less than a half of the mass of the electron. And the tori which have expressed with imaginary numbers have masses slightly greater than the mass, half of the mass of the electron. Okay? At the same time, whatever particles expressed with real numbers have positive energy. The particles, the tori. Tori with imaginary numbers has negative energy. But isn't it logical after that to put them together? Because the total energy must be equal to 0. Okay, if we are talking about elementary particles are created out of nothing. Okay, I didn't say there is no 0 point energy. I said elementary particles are created out of nothing. And this nothing must be maintained. I'm talking about from energy point of view. So isn't it logical now to put together particles, what I call reality polarized particles, together, and said out of two reality polarized particles created elementary particle. There are two types of polarization. One is called reality polarization, and this is where the leading string is inverted. They're separated by inversion of the leading string. There is a second polarization by trailing string, and this is, verticity polarization. When the string changes its verticity and spin changes. Okay, so out of these the difference between these two reality polarized toruses, tori, when put together, they will give you either negative charge or positive charge, a unity. When you have verticity polarized tori put together, they will give you 0. So now you have a combination of three types of particles with 0 charge, negative charge, and positive charge. Okay? And this is the example of a verticity polarized tori. 3 minutes. Okay. Can I use a theory of relativity, and so the time goes a little bit slower?
Well, if we use the special relativity,
okay.
then, we can make it go backward.
Okay. All right. Okay, can we go next?
Next one?
Yes, please. And these are examples of two tori with reality polarized tori. So real tori is wound around this inversion circle, or ZPE circle. The imaginary tori, okay, is wound it's encircling. Okay? This is the only difference. The second difference is this velocity will be less than velocity of light. This velocity which goes around this inversion radius will be greater than velocity of light. Now, next, please. Okay. Now we're talking about quantization, of course. Quantization, because so far we said, well, we continuously change the radius from 0 to infinity, from 0 to minus infinity. And of course, we know we are living in a quantum world, so everything must be quantized. There are two types of quantization, and we are one is called oscillation. Oscillation, it relates to a group of tori where in each group, inversion radius is different. So when the inversion radius changes from one dimension to another dimension, okay, it becomes smaller, 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 and smaller, okay? It relates to leptons. So you're talking about muons, tau particles, and so on. We are not going to talk about that. We are talking about oscillation. Oscillation relates to a group of tori with constant inversion radius, and which relates, in particular, what our world, it relates to inversion radius connected to electron mass. And what is changing, the only thing what is changing is outer the radius of the trailing spiral, okay? And these changes, here are equation for quantization of the tori, okay? They are very close to what you would get considering classical quantization, like in hydrogen atom as a function of angular momentum. Okay, the only thing I simplify this equation, so from mathematical, they give absolutely almost the same result, but it's much easier to manipulate. Now, during remaining 1 minute, what I want to tell you, now knowing all these rules, okay, you can draw a picture of electron, you can draw a picture of positron, you can draw a picture of quarks, you can combine these quarks and draw a picture of nucleons, okay? You can draw a picture what is going to happen, how these nucleons are held together. I need to go just one, probably 2 slides.
I must interrupt for a moment.
Okay.
With due consideration for everyone that's going to the social, those of you that would like to remain, he has 9 frames. If you would like to give Vladimir the opportunity to finish those 9 frames, please raise your hand. All that would like to leave, please raise your hand. Or if you don't want him to finish, raise your hand. Okay. I guess we'll go ahead and let Vladimir finish the 9 frames. And I think we still got enough time on the tape. Okay, he's got some good work.
By the way, I excuse Dr. Fox because he already heard my theory.
If you need to leave, feel free to leave. If you'd like, there's only 9 frames left. What, maybe 10 minutes?
Less.
Oh, less
5 minutes.
Okay. Thank you for your patience.
I appreciate it. Next, please.
Frame
yes.
or this one?
Yeah, next, please. Okay. Now we have to briefly talk about unification of strong forces, because once we have elementary particles, we have to explain how these particles are held together. Now, first of all, the question is how this particle exists. The particle now, once we talk about negative and positive energy, and we talk about that each particle contains torides with positive and negative energy, we are coming to a conclusion. Our particles are alive. They breathe. They consume energy, and they release energy. The part of the particle which is responsible for absorbing energy is particles either they are inverted either verticity-wise or reality-wise. Okay, the particles, the real particles or outverted particles are absorbing energy. Okay? So these particles exist by absorbing and releasing energy. To where? Of course, to zero-point energy field. Okay. Okay. Yes. Okay. Now, once we explain the existence of the particle, why it exists, okay, now we don't have to any longer to say that the law of conservation of energy is not maintained. We now understand why particle continuously rotates on the orbit without additional energy. It gets energy from space and releases energy back to space. Now, to explain strong forces, before I draw the picture of the spirals in toroidal form, now imagine this circle represents the orbital radius of the inverted toroidal torus, and this is outverted torus. The same thing here. What I did, I said, assumption I'm making that the electric charge is distributed evenly along this circle of paths. Okay? So what I did, I designed a computer model. I divided this circle of paths on a mini electric charges. So the total electric charge here is going to be equal to charge to electron. This is charge to positron total. And then I said, well, I will apply only very well-known Coulomb law, inverse square law. Okay? So to each particle, I calculated interaction between all of these particles, okay, using the Coulomb equations, and sum up this horizontal component. And what I found, if instead of using particles with like a point particles, you always, for example, will get between positrons always repulsive forces. If you have electrons, you always get repulsive forces. Okay? But when you work with the distributed charges, what is going to happen, just during your free time, imagine two circles started to overlap, and consider what is happening with the electric charges in overlapping part. They repel each other, but by repelling each other, they are going to try to bring circles together. Okay? It's very simple to imagine. So the next chart, please. So using computer program, I calculated what is going to happen with the forces as these two particles getting closer to each other. Of course, at distances which are much greater than the radius of the particle, you're going to have pure repulsive forces or pure attraction forces. But when these dimensions become comparable with the size of the particle, this is what is happening. In the beginning here, well, this is zero line. It's the negative corresponds to repulsion forces. Okay? So here up there, it's inverse square law. Then it's becoming cubic law, force power law. Then it reaches maximum level and inverts. Now instead of being repulsive forces, it's becoming attraction forces. Okay? This applies to the particles which make light parts of quarks. And this, what applies to the particles, you see the dimension, the values are, I don't see the numbers, but you can see the numbers. Compared to the numbers here, the 10 to the power 9, okay? This happens to the particles which are responsible for the mass of the quarks. And you can see here the same thing. It is repulsion forces, then you have this peak, and the equilibrium is going to be right here between repulsion and between attraction and repulsion forces. So this theory explains also repulsion and attractive forces. And finally, of course, I'm not going to show you how these quarks are. No, next one. Yes, this just describes quarks and how they are constructed from the tori. Please next. Next one. Yeah. Okay. And again, this is all equations showing. What is interesting is how I compare the results. There are three basic parameters I compare. Number one, of course, mass of the proton and the neutron. Second, electric charge, of course. But the third, very important parameter is magnetic moment. Until today, believe me, look at the literature. Nobody can explain how in the world neutron has negative magnetic moment. Everybody understands why proton has positive magnetic moment, but why in the world neutron has negative magnetic moment, comparable in value with magnetic moment of slightly less, maybe 30% less than magnetic moment of the proton. This theory explains. Because neutron is not a point. Neutron consists of the torides with negative and positive. The total electric charge of neutron is 0. But moment is not, because the negative electric charges are located on a larger radius, larger orbits, compared to the positive electric charges. As a result, the negative magnetic moment prevails. When you summarize of magnetic moments of each tori, you're getting negative magnetic moment, and the value within, I believe, between 1 or 2% of measured values. Do you have someone? Okay. All right. Okay. Now it's coming commercial part. Okay. This is my first book. It describes the history of the development of vortex theory. Okay. Next. This is the second book. It's a continuation. The first book actually covers only from ancient Greeks to 1725. This goes further to my goodness, 1900. Okay. Now, I suggest if you decide to purchase, I suggest you to buy the second book because it briefly, but it covers the first book. Okay. So don't waste money on buying the first book. Okay. And of course, you have this book called Unification of Strong Gravitation and Electric Forces. Unfortunately, it doesn't include this paper. You know, this paper, how to say, more advanced, because this book was published almost a year ago. Okay, so what I presented to you today, not everything is covered in these books. I thank you very much for your attention. Thank you.
Thank you, Dr. Ginsburg. Once again, I want to thank all of you. The evening social will be getting started in a few minutes over at the Super 8. They're having chicken and vegetarian meals. We'll see you over there.
Okay. All right, let's take